Okay, adding and subtracting percents. Okay. And there's some problems throughout these 4 sections that require the use of simply adding and subtracting percents. The last time we met, we talked about sales tax, and we looked at a couple of methods to find the total cost, right? You can either find the sales tax amount and then add that sales tax amount to your purchase price for the total amount. And then we looked at a method where we were actually adding percents. Okay, and we use 1 step instead of 2 steps. In module 2.3, there are a couple of problems, and this is the percent increase or decrease. On some of the problems, there's a formula you can use, but on other problems, such as this problem, if you're trying to increase a percentage, right, just keep in mind that one whole thing represents 100%, and you can add to that 100%, and you can take away from that 100%. For example, okay, and this should be similar to your question number 1 in module 2.3, and it's a salary increase. It says if a person earns $27,400 a year and gets a 7% increase in salary, what is the new salary? Now we can do this one of 2 ways. We can find 7% of 27,400, and then we can add that amount back, or we can actually add percents. So we have 100%, and that 100% comes from that person's salary, which is $27,400 a year. We want to increase that already 100% by 7%. All right, so I'm going to add these 2 together. So before we perform any calculations, we want to convert the percents to decimals. So 100 as a percent is 1, plus 7% as a decimal is 0.07, right? Because we dropped the percent and we move that decimal twice to the left. So if I add the 2, I get 1.07. So in order to find a person's new salary, I'm simply going to take the 27,400, and I'm going to multiply that by 1.07. All right, so instead of doing 2 steps, I'm going to find a person's new salary in 1 step. So if we multiply So if we multiply the 2, 27,400 times 1.07, that gives us $29,318. Okay. So you can add percents. All right. You can also subtract percents, right? So this is similar to number 4, and it deals with calorie content, and it says a certain light beer has 20% fewer calories than the regular beer. If the regular beer has 150 calories per bottle, how many calories are in the same size bottle of light beer? So here we're going to subtract percents. Okay, and we're going to subtract percents because it says that the light beer is 20% fewer. So we have 100%, right? And 100% is just 150 calories per bottle of regular beer. To that, we want to subtract 20%, right? Because it's 20% fewer. So I'm going to subtract 20%. So if I change both of these to decimals, well, 100% as a decimal is 1. 20% as a decimal is 0.2. And if you subtract, we get 0.8. So in order to find the calories in light beer, I'm going to multiply 150 times 0.8. So if we were to multiply that up, 150 times 80%, which is 0.8, is 120. All right, so there's 150 calories in regular beer, and then there's 120 calories, which is 20% fewer calories in light beer. Okay, so any questions about these two? And you're going to see questions like that a lot. That applies to sales tax. In the next section, that applies to savings accounts. All right, so you can add and subtract percents. All right, now here is the actual percent increase / decrease formula. Okay, it's percent increase or decrease. And we'll take a look at both examples. And the formula says it's the change in amount So now the change in amount is always going to be positive. If the change is an increase, so let's just say you were at a job, you started off with $10 an hour, and let's say you got an increase of $5 an hour. So that would be like a $5 difference, an increase. It can also be a decrease, vice versa. Let's say you make $15 at your job, and then they cut your salary by $5, right, which puts you at 10. The change in amount is always a positive number, but it's either positive if that number is an increase, or it's still positive even though it's a decrease, right? So it's the change in the amount over the original amount. So you always put the change in amount over the starting amount. So with this formula, let's take a look at a couple of problems. All right, so this is from module 2.3, and this is a rate increase example. And it says a reader is making $8.60 per hour and gets a 61-cent raise. What is the percent increase round to the nearest 10? Okay. Well, I'm just going to rewrite the formula. So the percent increase or decrease, I'm just shortening this up a little bit. That's equal to the change in amount divided by the original amount. So here the change in hourly wage was 61 cents. So that's going to be my numerator, 0.61. And I know this is an increase because the reader's wages increase per hour. I'm going to divide that by the original amount, in this case, which is $8.60. Right, so if we take the change in amount, which is 61 cents, divide that by $8.60, which was the starting wage, we get 0.0709. It's going to want your answers in a percentage. So I'm going to convert this decimal to a percent. So I'm going to move it twice to the right. And if I round, it looks like it'll be 7.1%. All right, because if I move the decimal twice to the right, I have 7.09. If I were to round this to the nearest tenths place, right, I will look one place to the right. Since that number is 5 or higher, it will round that 0 up to a 1. So there was a 7.1% increase in the hourly wage. Now here is an example of a decrease. All right, and this should be similar to your number 6. It says that shoes that usually sell for $72 are on sale for $54. What is the percent decrease in price? Right, so the formula says that the percent increase or decrease, that's equal to the change in amount over the original amount. Right. So if we look at our change in amount, it says that the shoes usually sell for $72, right? That was the starting amount. And now they're on sale for $54. So that's going to give me my change in price or my decrease. What should my denominator be? Well, the denominator is going to be the original amount. So if I read this again, it says shoes that usually sell for $72. So that $72 is the original amount. All right, so if we simplify the numerator, 72 minus 54, that's going to give us 18. All right, so notice that even though this is a decrease, the numerator is always going to be a positive number. Divided by 72. So we're going to take 18, divide that by 72. We get 0.25. We're going to convert that to a percent, so we should have 25%. All right, so it can be a percent increase or decrease, just depending upon your situation, but nonetheless, all of your percents must be positive. All right, any questions about percent increase or decrease? All right, now the last couple of things we're going to talk about are interest. There is simple interest and you get simple interest from banks. And the simple interest formula is I is equal to P times R times T, where I, that's the interest after time T. P is your principal, And the principal is the amount of money that you borrow. Can also be the amount of money that you invest. So this interest can go both ways, on borrowed money and invested money. R is the rate, the interest rate. Okay, and the banks will set the interest rate. So I'm not going to say this is like a trick a bank will do, but you notice that if you put your money in a savings account, the bank will probably give you 0.01% interest. If you change 0.01% to a decimal, that's a really small number, right? Because you have to move that decimal 2 places to the right. All right. So that's the interest rate usually set by the bank. And T is the time in years. The time must be in years. And so if you're given anything other than years, you have to convert it to a year. All right. All right, so let's take a look at some examples. Now, one thing about this formula, it only gives you the amount of interest. It's not going to give you the amount of money that's in the bank. In order to figure out how much money is in the bank, you have to take the interest and add it back to the principal. Okay, this is just a formula that gives you the interest amount. So on some of the problems, they ask you specifically for the interest amount. And on other problems, they ask you for the amount of money in the account. So I think I have both of these on here. All right, so this is similar to question number 1. It's a savings account example. A man invests $6,000 in a saving plan that pays 2% per year. How much money will be in the account at the end of 1 year? So I'm going to use a simple interest formula. I'm going to find the amount of interest after a year. And then once I find that amount, I have to add it back to the original $6,000. And that'll tell me how much money is in the account. So the first thing we're going to do is find the interest amount. So we're going to use that formula. I is equal to P times R times T, where P is going to be $6,000. That was the amount of money invested. R is the rate, which is 2%, but you must change that percent to a decimal. And the time is 1 year. We'll take a look at an example where the time is in something other than years. Okay. But for this one, we have exactly 1 year. All right, so we're going to calculate the interest. So that's 6,000 times 0.02 times 1. And I believe that should give us 120. Right. So it's $120 of interest. Right. So now in order to find out how much money is in the account, I got to do what? I have to take the original amount of money that was in the account and add to it the interest. So find the account balance. That's going to equal to 6,000 plus the $120 interest. So that's $6,120. And I doubt very seriously if a bank will give you 2%. Okay. All right. Any questions about number one? Putting your money in the bank is about the worst thing you could do. All right. For number 6, this is a student loan application. A student takes out an emergency loan for tuition, books, and supplies. The loan is for $200 with an interest rate of 9%. How much interest does the student pay if the loan is paid back in 60 days? Okay, so notice for our formula, time has to be in years. All right, so we're going to have to express days in years. All right, so we'll see how that works in a second. So now this question only asks for the interest that the student is going to pay back. It doesn't ask for the total amount that he pays back. Okay, so keep in mind what the questions are asking. Okay. So we're going to find the interest amount. So I is equal to P times R times T. P is going to be 200. All right, that's the principal. R is going to be 9%, which is 0.09. And the time. Now, a business year has 360 days. So like when you're calculating business years, it's 360, not the 365 and the leap year and all of that. It's just exactly 360. So in order to express days in terms of years, I'm going to take 60 days and I'm going to divide that by 360. All right, and that'll give me I think if I simplify this, I'm going to get 1, 6. If I simplify 60 over 360, I get 1/6 of a year. All right. So in my calculator, I'm just going to put all of that in. So this is 200 times 0.09 times 1/6. 200 times 0.09 times 1/6, and you should get $3. So at the end of 60 days, the interest due on that $200 is going to be $3. If you're doing this on the calculator on the computer, let's see, I believe I can do it the same way. 200 times 0.09 times 1 divided by 6. All right, so you should get $3. Right, so notice I did not change 1/6 to a decimal. Because if you change that to a decimal, you get the little repeat thing. So I kind of left it as 1/6. All right, and then on the next problem, we talk about compound interest. So here is compound interest. So the formula says that A is equal to P times 1 plus R over N raised to the N times T. Okay, so this has like an exponent to it. So now how do you know the difference? When do you use the simple interest formula and when do you use the compound interest formula? Well, the compound interest formula, if it is required, I thought I had XYZ homework up. The problem will basically tell you, it'll say compound interest. So if I just bring that up for a second, 155.05. Can I believe these are like after problem from 9 on down? All right. Where it says compound interest, these are where you're going to use. Okay, so 13 is different. That's a savings account. I mean, so it's a lot of formulas coming at you at one time. Like you could use the simple interest formula, or you could just multiply 803 by 1.0625. Number 15 is a compound interest problem. So if the application is specifically compound interest, this is the formula. So now, the variables are a little bit different here. A, that's the amount in the account at time t. So notice this formula gives you the amount that's going to be in your bank account. The other formula only gave you the interest amount. P is still the principal, right? The amount of money you borrow or invest. R is still the interest rate. N is the number of compoundings per year. So compound means that's the interest kind of turns over on itself. So like in these compound interest problems, they will have to give you the number of compoundings per year. So if the number of compoundings per year is annually, it's 2n, n is going to equal to 1. If it's semi-annually or biannually, n is going to equal to 2. If it's quarterly, n is equal to 4. All right, so in these particular problems that use the compound interest formula, they will have to give you the number of compoundings. Okay, so that's another indication that you should use this formula. And then lastly, T is the time, and that time has to be in years. Right, so 360 days constitutes a business year. All right, so let's take a look at problem number 9. Right, so it says compound interest, so we know we're using that compound interest formula. A woman puts $4,000 in a savings account that pays 5% compounded annually. How much money is in the account at the end of 2 years? Right. So we're going to use a compound interest formula. A is equal to P times 1 plus R over N raised to the NT. P is going to equal to 4,000. Our interest rate is 5%. Right? So I'm just going along. So principal is 4,000. the interest rate is 5%, is compounded annually. So N is going to equal to 1. And the time is 2 years. So we're going to plug all that into the formula. So the amount of money in the account after 2 years should be 4,000 times 1 plus 0.05 over 1. And that's raised to the N, which is 1, times T, which is 2. So if I simplify this just a little bit, this should be 4,000 times 1 plus 0.05 raised to the second power. So if I put this in the calculator, 4,000 times 1. Okay, just simplify that up a little bit more. 4,000 times 1.05 raised to the second power, and you should get $4,410. So this formula gives you the amount that's going to be in the account. So it adds that interest back to the principal. Okay, any questions about number 9? All right, and then the last one, number 12. All right, so here again, it's a compound interest formula or application. Suppose $1,800 is invested in a savings account that pays 4% compounded semi-annually. How much is in the account at the end of 1.5 years? Okay. So this is a compound interest problem. So P times 1 plus R over N raised to the NT. P is going to equal to 1,800. R is 4%. N is going to equal to 2 because it's compounded semi-annually. And T is in years. So I'm going to put in 1.5. So this is 1,800 times 1 plus 0.04 divided by 2 raised to the N times T. So that's 2 times 1.5. So I'm just going to simplify this up, son. So this is 1,800. 0.04 divided by 2 should be 0.02, right? 0.04 divided by 2. And then if I add 1 to that, I have 1.02. And then if I multiply 2 times 1.5, I get 3. And now I'm going to simplify. So this is 1,800 times 1.02 raised to the third power. So money is always rounded to the nearest hundreds, 2 places after decimal. So at the end of 1.5 years, there should be $1,910.17.